Good afternoon, children. So now we are going to discuss about LCR circuit. So in the last class we have seen how LR circuit, CR circuit and LC circuit works. We have seen the phasor diagram. Now we have all the three: inductor, capacitor and resistor. All the three are connected together in series to an AC source. So let I current flows through the circuit. That means I current flows through L, C and R. There is a voltage drop across inductor, that is VL, which is equal to IL omega. There is a voltage drop across capacitor, that is a VC, which is I into XC, that is I into 1 by C omega. After that, voltage across resistor IR. So remember the relation here, relationship between current and voltage. For example, consider R as a resistor here, VR is the voltage across the resistor, and the current is I. We know current and voltage are in phase in R circuit, resistor circuit. But when it comes to inductor, the voltage VL across inductor leads the current by pi by 2. So remember, you have to keep all this in your mind. And across capacitor, voltage is VC, and the voltage across capacitor lags the current by pi by 2. Voltage lags by pi by 2. So if you plot the phasor diagram, let us compare. First we will start with the resistor. The voltage across the resistor VR, let it be there, VR, and the current. In the case of resistor alone circuit, V voltage and the current are in phase, so we draw a straight line marking VR and I. Now the voltage across inductor, that is VL, is leading the current. So I is here, it is leading by 90 degree by pi by 2. So VL should be marked advanced with the current. But in the case of capacitor, voltage is lagging, so VC is down. Now because of all this, there is a resultant voltage, that is V here, which makes an angle phi. We do not know what is the value of phi, because if it is L alone we can mark a value, if it is C alone we can mark it as pi by 2, minus pi by 2, etc. Actually phi stands between the current and voltage, the lag or lead, that is what phi shows. But as all the three are there, we do not know what is the value of this phi. Is it pi by 2, minus pi by 2 and all, we do not know. So here look at VC and VL. VC is downward, VL is upward. So suppose if VL is greater and VC is lower, we get the resultant. As they are opposite in direction, we get the resultant VL minus VC. If VC is greater and VL is lesser, here we will mark VC minus VL. That depends on the value of L and C. So depending on L value and C value, voltage across inductor and capacitor, if you compare, voltage across inductor can be more, voltage across capacitor can be more. Suppose we take a simple case in which VL is greater, that is what marked with greater length, VC is lower. In that case, the resultant will be VL minus VC in this direction, which will be equal to this length here marked for the triangle. So this is our phasor diagram. Now we have a triangle here, VL minus VC and VR. This is our impedance triangle.